Hello everyone, Dr. Zia Tahir here. This video tutorial is first lecture of beam analysis in ANSYS Workbench series, and this tutorial is about simply supported wooden beam carrying a point load. The length of the beam is 3 meter and its section or its cross section is rectangular with width as 100 millimeter and depth as 250 millimeter. Modulus elasticity of wood is 12.5 gigapascal and Poisson's ratio is 0.3. So you need to find deflection under the load and then reaction forces or support reactions, and then to plot shear force diagram and bending moment diagram. So analytically, using method of joints, I calculated reaction forces and maximum bending moment. So I am use these values as reference to compare ANSYS results. Steps for analysis of simply supported beam in an ANSYS workbench. So these are main 7 steps. You need to start project, then engineering data, then is geometry, then model, setup, solution, and then results. So I'll follow all these steps to analyze beam. Video because it's the first lecture, so I have created chapter corresponding to each step. So if you are already familiar with any of the steps, so then you can simply go to a chapter which you want. First step is to start a project, and it's a static structural project. So here you are. So that is ANSYS workbench, and you can see it is an unsaved project. Here you have analysis systems, then you have project schematic here, and then here you have properties. So from this list of analysis system, I click on steady structural. So if you double click on steady structural, so you can see that it appears here in project schematic. So need to save this project. So file, save, and then in the destination folder, I am going to save that. So I'm saving it as beam 2D SS in a folder beam 2D simply support. So save. So this project is saved as beam 2D SS in my required folder where I want. Next is engineering data. Need to add material. I'm going to name that as wood and need to add modulus of elasticity 12.5 gigapascal and Poisson's ratio as 0.3. So here you have engineering data. So I double click on engineering data. So after double clicking on engineering data, you can see a new window will open, and in that new window here you can click here to add material. So I'm going to add wood, and there is a question mark on it. And then from the toolbox and linear elastic property, I need to drag isotropic elasticity in it. And then here you can see 2 sections are highlighted. So here need to add modulus of elasticity, which is 12.5 gigapascal, and the Poisson's ratio as 0.3. So once it's added, so now the new material is created. So you need to save it. Once saved, you can close it. So that you can see that is take on the engineering data. So material is created. Next step in the geometry, need to go and find select analysis type, and basic geometry option is the line bodies, and analysis type is 3D. So here by clicking on geometry, so you can see that a new window properties of symmetric geometry appear up here. So I'm going to select line bodies. You can uncheck that surface body or you can leave it as it is, and then analysis type is 3D. Although it's a 2D problem, but for beam, ANSYS solver is not able to solve it, or it gives errors. Next step in the geometry, need to sketch beam using DesignModeler. So here in the geometry, right click, and there are 3 options. You can either import geometry, which you have drawn in third-party software, then DesignModeler, and then space claim. So I'm going to click on DesignModeler. a new window of DesignModeler will open. That is DesignModeler. And in this DesignModeler, I'm going to use these tabs, and then in tree outline, some stuff from this tree outline. So in DesignModeler, need to start sketch, change units to meter, then concept, line from sketches and generate. So here is a DesignModeler. So first I need to change set units. So here you have units, and that is already in meters. Then the setting, so grid, show in 2D, and then snap. Major grid spacing I need to keep at 1 because I have to model a 3-meter beam, and 3-meter beam need to model in 2 meter and 1 meter. So I am not interested in that. So here minor step per major need to keep as 1. So then this sketch need to drawn in XY plane. So now that is XY plane, and with the mouse wheel you can zoom in or zoom out. And then to draw, you have option here, either line or a polyline you can use. So I am going to use polyline here. So that is a starting point, and then here it is the first segment of beam as 2 meter, and then that is the next segment of the beam as 2 meter, and then I leave at open end. So now 2 segments of beam, they are drawn. So with the dimension, it is possible to add dimension. So here in the dimension you need to display name and value, and then here I'm going either journal or horizontal. So if I'm going for horizontal, so then need to select first point, second point, and then add dimension. First point, second point, and add dimension. So here you can see that H1 is 2 meter, H2 is 1 meter. Otherwise you can draw lines randomly and then give them dimension later. So in my other lectures, so you could find out by starting random lines and then giving them dimension. So here you can change the dimension. So now that sketch is done. So here using here auto fit view, so you can view it. So then in the modeling, so in XY plane, you can see that it's there. So now going in concept, lines from sketches, and then with here box select, need to select whole beam. It is yellow now, apply, and then generate. So now that XY plane, a sketch is being generated, and it comes here as sketch. So you can rename that sketch as a beam or whatever you want. Next, to assign cross section, need to go concept, change units to millimeter, and cross section as rectangular. Beam is 100 millimeter and depth of beam is 250 millimeter. So in the DesignModeler, concept, then cross section, and here is the option of rectangular. But before that, you need to change units to millimeter. So concept, cross section, and rectangular. So now you can see here a rectangular cross section is already there, and its dimensions are 110 and 10. So I'm going to change it to 100, and the other one as 250. So press enter, and then here you can, so I can zoom that, and now you can see that its width is 100 and depth is 250. So that cross section is now here by default it is rect 1. So I'm going to change it to rectangle. Cross section change to rectangular, and then I need to click generate. So rectangular cross section is generated. Next is need to go to part body and assign cross section, and then in the view section need to check that if that cross section is properly applied to the beam. So here is a line body, and if you click on line body, so you can see that cross section not selected. So I have created only one as rectangular cross section. So and then I click on generate. So now in this way, so you can see that a beam is generated. So now I need to go to view and then cross section solids. So if I see that, so that is a cross section solid. So I'm not intended to draw in this way because I want that depth along y-axis because the loads are being applied in y direction. So you can change beam orientation. So you can change its display. So in the other videos, you can watch that how to change it. But here it is simple. You can go to the rectangular cross section and then simply change that uh, width with depth. So that is the easiest way. So now it is being changed. So generate that, and then I'm going to go to line body. Okay, so then you can see that its depth is along y-axis. Okay, so now that model is created, and so model can be saved, and then once saved, so you can simply close it. So now a beam is created in the geometry, and you can see a tick on geometry. So once it's done, so I have closed that, then I saved that project. So now geometry is created. Next one, you need to click on model and it will open ANSYS mechanical. So here click on double click on model, and it is here you can see starting mechanical. So here is ANSYS mechanical, and now in that ANSYS mechanical you have model, and then the next one is structural steel, and then is a solution. So in the geometry, so that is a line body which you have created there. So it's appear up here, and then you need to do material assignment, and you need to assign material as wood, and model type is beam. So that is a step which you need to perform. So better to check units. So here you can check units, okay, or otherwise in the home, and you have units here. So units are the standard one which I try to use. Next step in the model, need to click on mesh and then sizing geometry, select edges. So need to select edges and type is element size and then generate. So here you have mesh. So click on mesh, and here you click on mesh, and then you have sizing here. So click on sizing, and then it says that scoping method geometry selection. Here you can see scoping method geometry selection, and from here I am going to select edges, and then with the box select I am going to select all edges and then apply. And then here the next one type is element size. So you can go here number of division, so element size, and I'm going to keep that element size as 0.1. Okay, so with that 0.1, and then here click generate. So now you can see that here on this one, so you can see the number of nodes are generated. So now meshing is done. Now the next step is in model, go to selection, and then I am going to select few nodes and create name selection. So I can go for vertical nodes, and why I am going to do that step. We need to find deflection under the load. So I need to first identify that which node is under the load, and then I am going to create that name selection for it. So here you have model. So click on model. So if you click on model, then you have option of selection and then mesh by ID. So click mesh by ID, and then here I can select vertex. So to see that which vertex is for node, and then with box selection, so I'll select vertex. So you can see that the load is being applied at node node 1. So just 1 and create name selection. So now here in name selection you can find that selection, and I'm going to rename that as node 1. So you can select multiple nodes in the same way. You can select multiple nodes in the same way. So close that. So now that name selection is for node 1 only. So you can select multiple nodes, like you can select sports or whatever you want. Next step is in the model, using construction geometry, create a path, and path type is edge. And why I'm going to create that path, so that I can find out shear force and bending moment along that path. So here again in the model, so you need to go model, and then here you have construction geometry. Click on construction geometry, and then you have path. So that is the path. So now path type is using 2 point, but I'm not going, I am going for edge. And now using that edge selection here, and then box selection, I am going to select all edges. Okay, and geometry applied, and then you can see this is the start of the path and that is end of the path, and select all nodes in it, and that here you can see that is the path. So I'm going to rename that. So I renamed that as path as path length. Next step in the setup which is static structural, need to apply boundary condition, and for that environment sports, then simple sports. Scoping method is geometry, and need to select vertex and then give sport name. So one sport is simple sport. So this one is being applied. So here you have static structural, and then static structural, here are sports, and then click on simply sported, and now it asks you geometry selection, and the geometry selection go to vertex first, and then with the box select apply, and now a simply sported is being generated. So it can be read as pin sport. Other sport is roller sport. So to model that roller sport, this sport, and remember that it is a 2D problem and we are going to solve it as 3D problem. One, roller sport is being modeled as remote displacement. And here in the sport, you have that in the sport, the first option is remote displacement. Click on remote displacement, and the question, it says that geometry selection, so vertex, so that vertex need to select and then apply. So now here, because it is free to rotate about x-axis, so I'm going to leave that as free. Then y component is 0, and to restrict or to convert that 3D model to 2D model, z component need to be restrict, and then rotation about x and rotation about y, we need to restrict that, because this point can move in this direction because of roller sport, and it can rotate about z axis. Okay, so rest of all displacement, we need to constrain them or we need to fix them. So now I'm going to rename that as roller sport. Okay, so now boundary conditions, both boundary conditions are applied. Next step in the environment, load, force, and scoping method is geometry, vertex, and then component is a load name. So it is being applied at 2 meters from left support. So again here in the static structural, you have loads there, or that is a force, concentrated force is there. Click on that, and then it says that geometry selection, and here with the vertex, and then using box selection to try to select a vertex, so that is being selected, apply, and then now here defined by components. So x component is 0, y component is -12 E3. Okay, so enter. So then you can see a load is being applied, so which is similar as 12 kilonewton. So 12 kilonewton load is being applied. Now the next in the solution need to add directional deformation, and the scoping method is name selection, which is already created because deflection under the load is required and orientation is y-axis. So now here you have solution. So if you click on solution, so that window is going to change. So now deformation, so I'm first going for total deformation, although it is not required, but I'm going to do it to check deformed model. And then the next one, directional deformation, and for directional deformation, Scoping method default is geometry selection, so I'm going to change it to named selection. And then in name selection, you will find that node 1, and then orientation is x-axis. I'm looking for vertical deflection. So then here, directional deformation, I rename that y. So that directional deformation is being added. Next one, for force reaction, need to go prop and then select a boundary condition and name that to find support reaction. So here again, in the solution, click on the solution, and then here you have prop, and in the prop you can go force reaction. Okay, and in the force reaction, now it asks me that which support, so I am going to select pin support. So that is a force reaction. So I rename at pin support reaction, and again in the prop and force reaction again, and this time it is a roller support, and so it's renamed as roller support reaction. So that is a pin support reaction, and corresponding boundary condition is pin support. For roller support, corresponding boundary condition is roller support. Next step, in the beam results, in the solution beam results, shear force scoping method is a path which already created. That is a path which already created here, and then the type is directional shear force. So now here in the solution and in the beam results, there is shear force, and then here the scoping method is path, and path is already created, path length, and then it says that definition total shear stress. I'm looking for directional and in y direction. So that is a directional shear stress, shear force is being added in the solution. Next step, beam results and bending moment, and need to repeat all that same for directional bending moment. So now in the solution and again here in the beam results, so that is a bending moment, and then geometry selection is path, and then path is path length which is created. Instead of total bending moment, you need to go directional, and this is about z-axis. So total bending moment about z-axis, and here you can see that directional bending moment is being added. Next step is to shear moment diagram as combined, and in that case scoping method is a path length and type is total shear moment diagram. Again in the solution, by clicking on the solution and in the beam results, so you can have that shear moment diagram, and then it's a path is which have created, and then type is a total shear moment diagram. So in that way, total shear moment diagram is being added to the solution. So now all required parameters, so they are added in the solution. Next step is to solve, and that is very simple. Click on solution, and then you can see here in the solution, so there is a solve button. So just click that solve button, and you can see before that the status for these was now from green to yellow, and then you can see ticks here. So now it's mean that is solved. If I click on the total deformation, so you can see that total deformation, directional shear, directional bending moment, total shear bending moment, pin support reaction, and roller support reaction. So everything is in the next one. In the results, need to find reactions at supports. So it's very simple. Here are pin support reaction and roller support. So pin support reaction, here you can see that is a pin support reaction, and then for that pin support reaction, it is here in x direction is 0, in y direction it is 400. So 400 is a pin support reaction at pin support, and then again roller support reaction, and for roller support reaction it is 800 at roller support. So this reactions at support, they are exactly same which was calculated using method of joints. Next step is to find directional deformation and nodes, or that is the vertical deflection under the load. And for vertical deflection under the load, I have already created that directional deformation y, and the directional deformation y you can see here. So that is the value of directional deformation 3.35 into 10 to the raised power minus 3. That is the directional deformation. So again, in that, if you want to view that directional deformation, so that is the directional deformation, and in the display, so you can here treat it as thick and thin shell, and then you can in the preference you can node numbers. Okay, so they are already being there, and then in the results, so you can use a probe, and then you can find out. First you need you can find out the value, and then you can in the display, so you can have here deformed model or show undeformed wire. Okay, so this way you can visualize deflection, or you can find deflection. Next one, you need to plot shear force along the length, and simple here, that is a directional shear force. Okay, I'm not interested in that. So that is a directional shear force, and then you can see here is shear force diagram, and then these are the values for at each node. The next one is to plot bending moment or to find bending moment, and it is simple. Here you have that is the directional bending moment. So I just click on directional bending moment, and you can see that is the directional bending moment, and the maximum value of directional bending moment here is 8000, and that is somewhere along length 2. Okay, so here you can see that it is 8000, and this 8000 is when I performed hand calculation using method of joint, so I got the same result. So this is how bending moment looks like along the length. The next one is shear force, bending moment diagram, and deflection curve. So all those three, shear force, bending moment, and deflection curve, so you can visualize here in total shear moment diagram. So these are the first one is for this one is for total shear force, then is the total bending moment, and then is the total displacement, or that is the deflection curve, although it is being plotted in by taking the value as positive, so actual deflection curve will be inverted. So that is the first one is total shear force, then total bending moment, and then that is a deflection curve. So in this way you can visualize all, or then you can get that data. You can copy this data, paste in Excel, and then you can plot those in Excel as well. So in all steps or all results are get. So that is the end of the tutorial. Summary of this tutorial. This tutorial is analysis of simply supported beam in ANSYS workbench. So a simply supported beam carrying a point load is analyzed, and results are compared with the analytical results calculated using method of joints. And in deflection under the load, support reaction was required, need to plot shear force and bending moment diagram, and these are the steps. So need to start static structural project, and then need to add material, so which is wood in this case. Then analysis type is basic geometry option line bodies and analysis 3D. Then using DesignModeler need to sketch, and good thing in ANSYS is that you can change units, and then need to create parts. So then in the geometry need to assign material, and before going to geometry you need to check unit. The unit should be consistent. Then mesh. So in this case I use that element size of 1, and then selection. This selection is not necessary for analysis, but I just added here so that you can, rather than getting all the results, so you can only get your required result at any node. And then the construction geometry need to create path. So this path is necessary to plot shear force and bending moment diagram, or even for deflection curve. and then in the setup need to start static structural, and then simply supported support need to add. And there is a problem in ANSYS solver that you can't model it as 2D, so you need to model as 3D, and then for roller support you need to fix moments in X, Y, and Y plane, and then any displacement in Z. So that's why you need to apply remote displacement at roller support. So then applying load is very much simple. So you need to apply that concentrated force, and then to get directional deformation for the selection which is already made there. So on that, and then force reaction at each force using prop, and then using beam results. Shear force was calculated using bending beam result, bending moment was calculated, and then shear force and bending moment was added to the solution, and then solve, and then all these results were displayed. Thank you very much for watching. I hope you find this tutorial helpful. So you can leave your feedback in comment section.